Let's begin by revising the definitions from the previous lesson. Distance is a scalar quantity which measures how far apart 2 points are. Meanwhile, displacement is a vector quantity which measures how the position of an object has changed. We can represent this using an equation where delta x means change in position. An easy way to distinguish between these terms is to think of displacement as the net distance travelled plus a direction. Try to keep these definitions in mind because they will be important throughout this video. Mark Brent is running late to work again. Looks like he pressed the snooze button a few too many times. He reads the notifications on his phone. Oh no! He forgot about an important work meeting, which starts in 5 minutes. He'll be roasted by his boss if he misses it. While rubbing the sand from his eyes, Mark ponders. Is he able to get to the meeting on time? How fast will he need to run? Or should he speed through the streets on his scooter? Speed is a measure of how fast or slow an object moves. However, we need to adopt a more formal definition in physics. Speed is a scalar quantity equal to the rate of change in an object's position. Since speed is a scalar, it has a magnitude and units. The SI unit for speed is meters per second, but you will also encounter other units, such as kilometers per hour. We can calculate the average speed of an object using this equation, which you might have seen before. Here, we consider the average speed because the object might speed up or slow down. For example, when driving to the shops, the speed limit is 60 kilometers per hour. But you have to stop for traffic lights, so your average speed might be only 42 kilometers per hour. We'll discuss this further in our upcoming video on velocity time graphs. It's time to catch up with Mark. He's managed to suit up and brush his teeth in 1 minute. That's pretty impressive. Now, he's got 4 minutes left to travel 4.8 kilometres to work. Will he make it? To find out, let's calculate the average speed that Mark will need to travel at. If we divide distance by time, we get 1.2 kilometres per minute, which is rather difficult to interpret. Instead, let's find his speed in kilometres per hour. We need to convert the time from minutes to hours. 4 minutes is equal to 4/60ths of an hour. Entering this into a calculator gives 72 kilometres per hour. There's no way Mark can run that fast. Usain Bolt clocked in at a top speed of 44.7 kilometres per hour. He can't drive that fast either. The speed limit is 60 kilometres per hour and he's a law-abiding citizen. Instead, Mark decides to borrow his superpowers for a not-so-super cause and flies to work. After all, his top speed is around 4,000 kilometres per hour. In physics, you'll need to know how to convert between kilometres per hour and metres per second. As we mentioned earlier, the SI units for speed are metres per second, and we should stick to this for all calculations. Firstly, remember that speed is distance travelled over time taken. Therefore, we can write the speed 72 kilometres per hour as a fraction. Then, we convert the distance, 72 kilometres, into 72,000 metres. Finally, since there are 60 minutes in an hour and 60 seconds in a minute, 1 hour is the same as 3,600 seconds. Simplifying the fraction gives us the speed 20 metres per second. Alternatively, you can use a handy shortcut. To convert from kilometres per hour to metres per second, divide by the number 3.6. To convert back, multiply by 3.6. In exams, if you're not sure whether to multiply or divide, remember that the speed in metres per second is always less than the speed in kilometres per hour. It's time we take a look at velocity. Velocity is a vector quantity equal to the rate of change in an object's position. Since it is a vector, it has a magnitude, units, and direction. The SI unit for velocity is meters per second, while the direction is the same as the object's displacement. We can calculate the average velocity of an object using this equation. Just like before, it's an average because the object might speed up or slow down. Meanwhile, at the Federal Security Agency, Lotus Lang is busy working on a new case. Last night, while she was out at dinner, there was an explosion above the city. The government's cover story is that 3 people broke into a fireworks factory and set off an entire shipping container's worth of fireworks. It's her job to investigate the real cause and catch the people responsible. Lotus analyses the radar imagery from the night before. Most paths correspond to helicopter and airplane flights, but one trail stands out. Something was moving quickly in a straight line towards the city's nuclear power station. Just before it detonated, something made it go off course. Maybe a malfunction. Lotus reads the coordinates on the radar map and finds the object's displacement to be 38 kilometres at a bearing of 210 degrees. It travelled this far in only 40 seconds. To find the average velocity, Lotus needs to divide the displacement by the time taken. Making sure to use SI units, she calculates the average velocity to be 950 metres per second at a bearing of 210 degrees. That's almost 3 times the speed of sound. This only confirms her fears. This is too fast for an aircraft. Only a missile launched in aggression can move this quickly. Since she knows which direction the missile was flying, Lotus can find its source. It's the middle of the ocean. Without a moment's delay, she sprints out the door and boards an aircraft. She's going to track down the submarine that launched the missile. Let's quickly revisit the equations for average speed and velocity. Velocity is represented by a lowercase v with a right-pointing arrow on top. The arrow reminds us that velocity is a vector and has a direction, while the subscript AV means it's an average. If you remember from the previous lesson, the Greek letter delta represents change in. In physics, delta t means change in time, or the time taken for an object to move. Furthermore, since displacement is the change in an object's position, we can write this using delta notation. Now, because the letter S is used to represent displacement, we cannot use this for speed. Instead, speed is written as lowercase v. There's no arrow on top since it's a scalar. Keep in mind, these equations are not shown in the HSC physics formulae sheet. Therefore, you'll need to memorise them for exams. Now let's step back and compare the quantities we've encountered so far. Distance is a scalar. We use this to calculate average speed, which is also a scalar. In a similar way, displacement is a vector, and we use it to calculate average velocity. As you can see, there are many parallels between the terms. As you might already know, an object's speed cannot be negative. It's always greater than or equal to 0. In comparison, the displacement and velocity of an object can take any value. A velocity of plus 5 metres per second left means the object is travelling left. A velocity of minus 5 metres per second left means the object is actually travelling right. Remember, a negative sign means in the opposite direction. Finally, consider a pizza delivery service. The delivery person drives to your place, drops off the pizza, then drives back to the restaurant. All up, it might take them 10 minutes for a 4-kilometre round trip. But since they return to their starting position, their displacement is 0. Therefore, the delivery person's average velocity is 0 metres divided by 10 minutes or 600 seconds, which is 0 metres per second. This illustrates our final point. If an object returns to its starting position, then its average velocity is 0. Let's pause for a moment to consider the types of questions you might be asked in exams. Questions will ask things like, what are the differences between speed and velocity? What is an object's average speed or velocity? When calculating velocity, you'll need to consider what direction the object travels in. Don't forget to include units and a direction in your answer. Before we finish, let's work through a sample question. To qualify for the school's swim team, Janice needs to swim 9 laps of a 50-metre pool in under 8.5 minutes. For the entire swim, calculate the minimum value for her average speed and her average velocity. Pause here to think about your answer. To begin, we should underline all the key information in the question. 9 laps, 50-metre pool, 8.5 minutes. We should also remember that 1 lap of a swimming pool is 50 metres. Next, we should draw a diagram and decide on a sign convention. While swimming, Janice's direction will alternate between forwards and backwards. To answer the first part of the question, we'll need the formula for average speed, the distance travelled divided by the time taken. Janice needs to swim 9 laps, each being 50 metres, so the total distance is 450 metres. She has 8.5 minutes, but we should convert this to the SI unit of seconds. After multiplying by 60, we find the time taken is 510 seconds. Therefore, her required average speed is 0.88 metres per second. For the second part of this question, we'll need the formula for average velocity. Since Janice will swim an odd number of laps, she will finish at the opposite side of the pool to where she started. Therefore, her displacement is 50 metres forward. Overall, her required average velocity is 0.10 metres per second forward. This is much smaller than her average speed because she travelled backwards and forwards multiple times. As a result, her displacement is much less than the total distance that she travelled. Let's revise what we've covered in this lesson. In the HSC Physics course, you will need to understand the key differences between speed and velocity and perform calculations involving both quantities. Speed is a scalar quantity equal to the rate of change in an object's position. It has SI units of metres per second and is represented in equations by lowercase v. Meanwhile, velocity is a vector quantity equal to the rate of change in an object's position. It also has SI units of metres per second and is represented by a lowercase v with an arrow on top. To convert a speed or velocity from kilometres per hour to metres per second, divide by the number 3.6. To convert back, multiply by 3.6. If you're not sure whether to multiply or divide, remember that the value in metres per second is always smaller. An object's speed cannot be negative. On the other hand, velocity can be negative. The minus sign means in the opposite direction. If an object returns to its initial position, its average velocity is 0. We hope you enjoyed this Schooling Online production. For more easy lessons on physics, check out our video on acceleration.